This is problem number 4 from spring 2018. We have a cannon shoots a projectile in the air. When the projectile is at its highest point, its velocity is 50 meters per second in the I direction, purely along the x-axis. At that point, it explodes, and we're told that it breaks into 2 pieces. We're given the velocity of one of the pieces, the piece A, and we're asked to solve for the velocity of the second piece, piece B. Well, we know the initial momentum, which is the total momentum of the system, is just mv, which is 1 kilogram times 50 meters per second in the I direction. And so that gives us 50 kilograms per meter second, or kilogram meters per second in the I direction. We're also told the velocity immediately after the explosion of piece A, and so we can calculate the momentum, PA, as being MAVA, which is the mass, times the velocity, which we were told is 40 meters per second in the I direction and negative 50 meters per second in the J direction. And so if we just multiply this out, we get that the momentum is 16 kilogram meters per second in the I direction minus 20 kilogram meters per second in the J direction. We know that momentum is conserved, so our initial momentum, which is capital P, is equal to the sum of the total final momentum, PA plus PB. We write this out. This is 50 kilogram meters per second I hat equals 16 kilogram meters per second I hat minus 20 kilograms meters per second J hat plus the x component of B in the I hat direction and the y component of B in the J hat direction. And now we can actually solve for each of the components separately. So our initial I component of the momentum is 50 kilogram meters per second. Our final one for A is 16, so B has to be 50 minus 16, or 34 kilogram meters per second in the I direction, so that this I hat term and this I hat term add up to this I hat term. So 60 plus 34 is going to give us 50. So that's the I hat component, or the x component of B. The y component of B is, well, our initial momentum at the highest point, there's zero velocity in the y direction, there's zero momentum in the y direction, and therefore if piece A has a component of negative 20 kilogram meters per second in the j hat direction, PB has to have positive 20 meters per second in the j hat direction, so that those cancel out, leaving no j term on the other side. So we have PBX is 34 kilogram meters per second in the I hat direction, PBY is plus 20 kilogram meters per second in the j hat direction. We can write the full vector out by putting those pieces together, and then to get the velocity, we just take the momentum, which is 34 kilogram meters per second in the I direction, plus 20 kilogram meters per second in the j direction, divided by the mass, which is 0.6 kilograms, and we get 56 meters per second in the I direction plus 33.3 meters per second in the j direction, and that gives us a solution of A.